In the last session, I explained about turboprop and turboshaft engines. In this session, I'll be explaining about ramjet and scramjet engines. First, we shall see a ramjet engine. A ramjet engine is variant of jet engine that eliminates the rotating parts like compressor and turbine from regular jet engine. Next, we shall see the parts and functions of ramjet engine. The air entering the ramjet engine is at supersonic speeds. This air is deaccelerated at the diffuser inlet, which causes high pressure ratio in the combustion chamber. This pressure ratio is sufficient for raising the air pressure to required combustion pressure. This process of converting the kinetic energy or Mach number of the inlet air into pressure rise is called ram effect, and the pressure rise during this effect is termed as a ram pressure rise. This principle of a ram pressure rise is used in ramjet engines, which is achieved in diffuser section of ramjet engine. In ramjet engines, combustion occurs at subsonic speeds in the combustion chamber, where the temperature is 1500 Kelvin to 2000 Kelvin. Next, the exhaust gases are expelled out through the nozzle section. Next, we shall see the advantages and disadvantages of ramjet engine. The advantages of ramjet engine are: ramjet engine is very simple in construction and does not have any moving parts. It is very cheap to produce and requires almost no maintenance. The specific fuel consumption is good at high speeds and high altitudes. Theoretically, there is no upper limit to the flight speed of the ramjet engines. The disadvantages of ramjet engines are: since the compression of air is obtained by virtue of its speed relative to the engine, the takeoff thrust is zero. It is not possible to start a ramjet engine without an external launching device. Due to high air pressure, the combustion chamber requires flame holder to stabilize the combustion process. Next, we shall see few applications of ramjet engine. Ramjet engine is independent of fuel technology. Wide range of liquid, also solid fuels can be used in ramjet engines. Its fuel consumption decreases with flight speeds between Mach 2 to 5, thus suitable for propelling supersonic missiles. Subsonic ramjets are used in target weapons apart from turbojets or rockets for getting the starting torque. Ramjet engines are meant for hypersonic flight transport. Next, we shall see scramjet engine. Scramjet engine is also variant of jet engine that eliminates rotating parts like compressor and turbine from regular jet engine. When the flight Mach number attains greater than 4 or hypersonic speeds, the operation of ramjet becomes difficult at hypersonic Mach numbers. To propel the vehicle at hypersonic speeds, the air must be at supersonic speeds when it enters the combustor. Thus, the combustion process occurs itself when the flow is supersonic, hence the name supersonic combustion ramjet engine, or simply called as scramjet engine. Next, we shall see the parts of scramjet engine. In scramjet engine, the air coming at hypersonic Mach number is compressed by series of oblique shafts produced at the inlet of the scramjet engine. Then the compressed air enters the combustor round about Mach of 2 to 2.5. The fuel is mixed with supersonic air and burned inside the combustor. The hot supersonic flow is allowed to expand through the nozzle, thus generating thrust required for propelling the vehicle at hypersonic speeds. Next, we shall study the advantages and disadvantages of Scramjet engine. Advantages of Scramjet engine are: manufacturing of Scramjet engine is easy as it has no moving parts. The construction of Scramjet engine is simple as the Scramjet engine eliminates the rotating parts like compressors and turbines. The weight of the Scramjet engine is low. Scramjet engine reduces pollution because steam is expelled out of the engine, which is an eco-friendly in nature. Disadvantages of Scramjet engine are: Scramjet engine cannot generate sufficient thrust unless the airspeed reaches hypersonic speed, that is Mach 5. Scramjet engine requires additional propulsion system. The testing of Scramjet engine is difficult. Let us see some applications of Scramjet engine. Scramjet engines are used in civil aircrafts like Tupolev 144 and Concorde, etc. This type of engines are used to propel missiles such as BrahMos supersonic cruise missile, British Bloodhound, British MBDA, etc. Next, we shall see the evolution of Ramjet and Scramjet engines. From early 19th century till current times, evolution in the development of subsonic speeds to the hypersonic flight speeds resulted in the evolution of Ramjet and Scramjet engines. In April 29, 1949, Ledet built prototype of Ramjet engine. The first Ramjet powered flight was achieved at Mach 0.84. In 2004, Pegasus booster launched from B-52 used X-43 Scramjet engine, which reached the speed of 9.68. Next, we have the comparison between aircraft engines. The comparison of different aircraft engines with respect to parameters are as shown in the table. Piston engine operates at low speed and low altitude. The fuel efficiency of piston engine is high. Turbojet engine operates at high speeds, that is above 800 to 1100 km per hour. Turbojet engine operates at low altitude, that is less than 32,808 feet. Jet velocity of turbojet engine is 350 to 600 meter per second at sea level. Thrust generated by turbojet engine is 2000 pounds, which is 8,896 Newton. The fuel efficiency of turbojet engine is high. Turbofan engine operates both at low and high speeds, that is from 500 to 1000 km per hour. Turbofan engine operates at low altitudes, that is 36,089.2 feet. The jet velocity produced by turbofan engine is 200 to 600 meter per second. Thrust generated by turbofan engine is 4,000 pounds, which is 2 times the thrust generated by turbojet engine. Fuel efficiency of turbofan engine is high. Turboprop engine operate at low speeds, that is between 600 to 800 km per hour. Turboprop engine operates at low altitudes between 6,000 to 30,000 feet. Jet velocity of turboprop engine is 200 meter per second, and the fuel efficiency of turboprop engines is low. Here I have not included the thrust generated by turboprop engine. You guys can find out the thrust value generated by turboprop engine and put up your answer in the comment section. With this, I will end up this session here. In the next session, I'll be explaining about non-air breathing engine, that is rocket engine. Thank you.